Hello, friends. Today we are going to talk about consolidation process. So, what is consolidation? In shallow foundation videos, you have seen we have computed the settlement of a foundation resting over the clay soil mass. So, here the process of consolidation can be defined by taking the site example. Let's say at the site, the ground level, and if you go deeper the ground, you have got the sandy strata, below the ground level, and then you have got clay soil mass, and then again you have got sandy soil mass. And say the water table is somewhere here, is the groundwater table. So if you take any point in the clay mass is completely saturated, fully saturated. If you take any point here, what is the total pressure? It is due to overburden. So the total pressure, let's say this point is A in the clay mass. So at A, the total pressure is going to be due to overburden of the soil mass. So at A, what is the overburden? It is sigma. Oh, this is the total overburden pressure, which eventually you know is the total unit weight multiplied by the column of soil mass above the point A, that is called jet. Now, if you put a piezometric tube over here at point A, the water table will rise up to this level. In the piezometric tube. So if I insert a tube at A, the head of water. So at point A, the head of water, the groundwater table, and the water table is going to match with the groundwater table, and this is the head of water, and therefore the pore water pressure, which we call it as U, is going to be unit weight of water multiplied by the head of water above that point. Therefore, if you say the total pressure is called sigma, so sigma equal to due to overburden. Now, pore water pressure is called U. Therefore, what is the effective pressure at A? That you can find it out. Sigma prime will be the total pressure sigma minus pore water pressure. So, sigma can be written as gamma T into Z minus gamma W into HW. So effective pressure at A where there is no external loading. Now if you increase the external load over this soil mass, say we put the external load, an external load can come to the ground level or to any level of the ground due to footing. If you are going to have a foundation, this footing, let's say you are applying an increase in total pressure is called, say, delta sigma. Now the moment you apply this pressure, as you know, will be transferred to the pore water. So now, because the water, this pressure which you have applied over the ground surface, so at A, your pore water pressure will now shoot up. So the moment this delta sigma is applied, the pressure from the footing or anything, you will find this pore water will shoot up. And this pore water which has shot up uh, is due to this particular intensity of loading that I have applied at the ground surface. Naturally, now you can see that the pressure has increased. The pore water pressure has increased. It has shot up, and this pore water pressure, that is delta U, it has increased, and this increase in pressure, pore water pressure, is due to this delta sigma. So at point A, your pore water pressure has increased due to this particular loading, and this pore water pressure increase is going to dissipate as the time, because the hydraulic conductivity of the clay soil mass is going to be quite less. Therefore, it will gradually dissipate. And because you have got the permeable layer below the clay soil mass and above it is sand here. So gradually it is going to dissipate. And this excess pore water pressure that has shot up will finally come to the normal position. And this, once it comes down, so now the effective pressure, if you want to calculate at time t equal to 0, the moment you have applied this additional pressure, so at time t equal to 0, the moment you applied this intensity of loading, what will be this one? The total pressure minus pore water pressure. So what is the total pressure at A? It is going to be delta sigma. And what is U? U is the increase in pressure is also delta sigma. So the effective pressure becomes 0. So the total pressure increases, and the effective pressure is there is no it's going to be 0 as time increases. So as time increases, you will find that gradually this excess pore water pressure will dissipate, and at time t equal to infinity, this all excess pore water pressure delta u, that becomes equal to 0. So therefore, the effective pressure becomes, because the total pressure becomes 0, so total pore water pressure sigma minus this delta u, here also you can write it delta u. So this becomes equal to sigma minus 0. Therefore, sigma prime equal to sigma. This sigma is equal to delta sigma. So this can be equal to delta sigma. So the increase in pressure, or we can write it here delta sigma prime equal to delta sigma. So all this, whatever you have applied, has gone to the now soil skeleton, and because the pressure, water has transferred that pressure to the soil skeleton, the uh, soil is going to settle, and that process is known as consolidation. So it's a very important process that I wanted to highlight today. And in the next video, we will talk about what are the important parameters that can be used to compute the consolidation settlement. Thank you very much.